Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a real-world crowd sale that can be deployed to the Ethereum mainnet in order to raise funds in an ICO. In the last video, we completed building the ERC20 token for this crowd sale. And in this video, we're going to start actually building the crowd sale itself. So check out that last video if you haven't already, and be sure to subscribe to the channel to see the next videos in this series when they come out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. So before we start coding the crowd sale, let's just take a look at some high-level kind of bullet points about how our crowd sale is going to work. Now, remember, this is a real-world ICO that has to support a lot of different characteristics, and I'm going to list out these characteristics right here for this crowd sale. Now, in a basic sense, it's going to be a crowd sale where you can, send Ether to the smart contract, and it will, compute the amount of tokens that you need based on the rate. It's going to be a timed crowd sale where it has an opening time and a closing time. It'll be a capped crowd sale. That basically means it will have a maximum amount of funds that it can raise in the crowd sale. It's going to be a minted crowd sale. So if you remember in the last video, we created a mintable token. So that basically means anytime that a token is purchased in the crowd sale, we'll actually mint them instead of having a set total supply. And kind of what that means is, the total amount of tokens that you have in the crowd sale is going to be determined by how many are actually sold. And it's also going to be a whitelisted crowd sale. So if you're holding a real-world ICO, you're probably going to have to deal with KYC, KYC requirements. Know your customer. You got to register people so that you can match contributions in your crowd sale to real people. That's what the whitelist is for. So I'll show you how to do that. It's also going to be a refundable crowd sale. And what that means is that the ICO is going to have a minimum funding goal, and if the minimum funding goal is not met, then all of the funds sold in the public round are going to be refunded. Basically, they're going to get stored in a vault, and if the ICO is not successful, then investors can come and claim a refund for their tokens. And additionally, I'm going to show you how to do a pre-sale versus a public sale. Basically, our ICO is going to have two stages. The pre-sale is going to have a different redemption rate, as in, you get more tokens for the amount of Ether, same amount of Ether in the pre-sale versus the public sale. And also in the pre-sale, you're going to, all the funds are going to go straight to the wallet, the person who's deploying this token sale, not just the refund vault. And I'm also going to show you how to do the token distribution and vesting on chain. So, you might have seen a graph like this where people say, X amount of tokens are going to the founders, X amount are going to the company, and X amount are going to the public. We'll actually do that in the crowd sale. So, yeah, that's what we've got to cover. I'm not sure how many videos this is going to turn into because this is a lot. Building a crowd sale is a lot of work because you have to really know what you're doing in order to get all this right. But fear not, I'm going to show you how to do it. So in the last video, we finished building this ERC20 token in our contracts directory. Now we want to create a new file. We'll call this, actually, let's do it new here. Say Dapp token crowd sale. Sol. All right, and inside of here, we want to use the same Solidity version, so I'm going to copy this and paste it here. And I'm also going to, declare a new contract. Say contract, Dapp token crowd sale. And, we'll just open this up here. And just like our token, we're going to drive this with the OpenZeppelin Solidity library. And the first thing we want to do is import this. We want to import the basic OpenZeppelin Solidity crowd sale. I can show you that file. So basically, this is going to keep track of, this is going to implement the basic functionality of a crowd sale. It's going to have the buy tokens function. And right here. And we can kind of step through this and see what it does. Basically, it accepts an address. This is the beneficiary, the person who's actually going to receive the tokens. And this is the amount of way that's getting sent, MSG.value. MSG is a global object in Solidity that has a value, which basically is the amount of ether being sent when this function is called. And this essentially what this does is it calculates the amount that's going to get created, how many tokens you're going to buy based on the rate, and it's going to add the amount of way raising the crowd sale to this public state variable, and then it's going to actually do the token purchase, and it's going to update some state, send the funds where they need to be sent, and it's going to also validate this purchase. So all these functions here that are underscored are basically functions that we can override. You can actually read that here in the dev comments, validation of incoming purchase, use require statements to revert when some conditions aren't met, and basically these are intended to be overridden if you want to, but these that are not underscored are definitely not intended to be overridden. Like if you just see it here in the dev notes, like do not override. So we won't do that. So yeah, this crowd sale implements the basic buy tokens functionality. It adds some requirements like pre-validate purchase. The beneficiary address has to be present. You can't buy tokens for a zero amount. See, this is an optional override. This is blank for now. When we deliver tokens, so basically in this basic crowd sale, we're going to just go ahead and transfer tokens from the beneficiary, and it's going to have the calculated token amount. Process purchase is going to be deliver tokens. It's just as a wrapper for this. Update purchasing state. This is optional. Get token amount. Now, this is basically going to say however much ether you sent me, I'm going to multiply that amount by the rate. This is the redemption rate. And also forward funds. This basically means whatever ether you sent is going to get sent to the specific place where funds are sent in this crowd sale. And in the basic crowd sale, it's just sent to the wallet that we pass in whenever we deploy the contract. So I'll also mention that whenever this basically how this works is you don't necessarily have to call this buy tokens function on the smart contract when you're contributing to the crowd sale. What you can do is just send ether to it. And I actually created another video on my channel because people ask me this a lot. Is like, how do you get a smart contract to just purchase tokens in a crowd sale by just sending an ether? You see that a lot. You say send 1 ether to this contract address, and I want it to buy some tokens. Well, that's how this works. Basically, this is a function. It's an empty function, has no name. So basically that, and it's payable, right? Which means it can be executed whenever you send ether to it. So what it does is whenever you send ether to the smart contract address, just creating a transaction with this address with, like say 1 ether, it is an empty wrapper function that calls whatever's inside of here, and this basically calls the buy tokens function and passes in the address of the person who's sending it, right? So basically you're saying, if I'm sending this contract 1 ether, I'm the beneficiary and I want to buy tokens, and it's going to go through all this stuff and calculate how many tokens I actually want by let's get token amount. And it's basically multiplying however much way you sent by the rate. All right, now that's a lot. So let's kind of just implement a lot of this basic stuff, and we'll do it in our tests. So what we want to do is go here and just say, Dapp token crowd sale is crowd sale. All right. And let's see what we need whenever we want to create the constructor arguments for this. Basically, we need a rate, we need a wallet, and we need the token address. And we can pass these in to our constructor like this. We can say constructor and say call this public. Go ahead and break it up here. And actually, while I'm here, I'm going to go ahead and use 2 spaces because I'm kind of tired of using 4 spaces in Solidity. Most people in JavaScript move to 2 spaces, so I'm going to as well. So basically, we're going to say constructor, and we're going to pass it. Let's just copy these arguments, actually. Rate. All right. And yeah, that's what we need. And what we can do is whenever we, we want to pass these along to this inherited contract. So just like our Dapp token, we want to say Crowdsale and then pass in name, symbol, and decimals. Or not, but these arguments, rate, wallet, and token. So let's do that. We'll say Crowdsale. Say rate, wallet, decimals. All right. I'm going to go ahead and break this up like this, because we're going to add to this list quite a bit, and it's a lot easier to diff if I break it up like this. I'm going to go ahead and move this public modifier down, and we'll also go ahead and do this. All right, so that's probably all we need for right now. Let's go ahead and see if this compiles. Make sure I did everything correctly. All right, so it looks like I made an error here. I used the wrong argument there, my fault. I was thinking about the token. Save that, compile it again. All right, so it compiled. Well, now we know we've at least successfully imported this Crowdsale. So let's go and write a test. So we can open the token.test.js. Let's go ahead and create a new file in this directory. We'll say Dapp token Crowdsale. Oops, not sol. Sorry, guys. I did the wrong thing here. Let's go ahead and rename this file. All right, so let's go ahead and create a test for this. Just like our previous test, we want to import the contract. So we'll say Dapp token Crowdsale. All right. And we also want to, let's just copy some of the setup from the other test. We want to import this. We want to use import chai. I'm just going to do that up here. And we also want to import this, like we did in the last. So we're going to need to compare big numbers. We're going to use chai. We need to pull this in. Let's go ahead and declare the contract. And we'll say Dapp token Crowdsale. And we'll go ahead and pass in the accounts. Actually, I'm going to move this over. All right. And what I want to do now is use this same kind of pattern. We say before each. We want to deploy this asynchronously. And instead of saying that, yeah, the first thing we need to do in order to, deploy this contract is we need a token, because we have to pass the token address here whenever we generate the ERC20 token for this Crowdsale. Like if you go back and look inside the constructor, it sets the token address to this token because it needs to perform some actions on this token and it needs to know about it. So we'll save that. So we're actually going to also need to import the token. We're actually going to import the token like this. Let's just say take off Crowdsale. All right. And inside of here, we're going to need to say Dapp token new. And I'm going to do this. All right. And I'm actually going to say this name equals Dapp token. And this symbol, Dapp, this decimals. All right. Now, let's just say token configuration. And we'll say deploy token. All right. So now what we want to do is actually deploy the Crowdsale. And we can say Crowdsale config. And we'll say this dot, let's see what we need. Let's go back to this constructor. We need a rate, we need the wallet, and we need the token. We'll say this rate. We'll just leave this blank for now. This, say this wallet. All right, and we'll say this dot token. Let's leave this blank. Sorry. And now what we want to do is actually deploy this as well. So we'll just copy this. And instead of Dapp token.new, we want to do Dapp token Crowdsale .new and pass it the rate, this wallet, and this dot token. I'm actually going to do that here as well. All right, and the reason I'm assigning all these to this dot is so that we can reference them later in the tests whenever we start writing examples. And there might be a better way of doing that, but that's just kind of how I'll do it in this particular tutorial. So yeah, what we need to do is first deploy this token, and then we'll deploy the Crowdsale because we want to pass the token address for this deployed token to this variable, which is going to go inside the Crowdsale constructor. So let's do that. Get the token address like this. Instead of saying this dot token, that's going to be duplication, and it's going to override this. So let's not worry about declaring that here. We'll just do this dot token. Since we did the async await pattern, we can just read the address directly off of it like this. All right, and that should work. So there should also be a wallet. Now the wallet is just going to be an address for the wallet's going to be an address where the funds are sent during the pre-sale, and also whenever the Crowdsale is over, the final funds will get sent to this wallet as well. And we can read that out of accounts. And instead of just using, like, this is going to be an array whenever it gets passed in, and instead of reading values out of this array manually inside of our test, we can actually just do this and actually import these accounts individually inside of here. So the first argument I'm just going to leave as an underscore. That's going to be kind of like the deployer, the first account, and the second account is what I'm going to use for the wallet. All right. So yeah, we're just referencing accounts individually inside of this whenever we pull this in. So this dot wallet is going to just be wallet. All right, it's going to be an address. And this dot rate. Now let's talk about the rate for a second. So the rate is going to be essentially because we're using 18 decimal places, this is the same amount as Ether, right? Ether can be divided by 18 to get way. By the same measure, Dapp token can be divided by 18 to get, its smallest denomination. The rate's basically going to be like, how many tokens can I get for 1 Ether? So for this particular example, I'm going to say that you can get 500 Dapp tokens for 1 Ether. And you can kind of think about that, if you want to think about like US dollar, right? Let's just assume that Ether costs like 500 US dollar, like roughly speaking, that's about where it is right now, maybe a little less. So you could say, since Ether is worth $500 for 1 Ether, if I get 500 tokens, each token costs $1. All right, now let's go ahead and actually try to deploy this and run the test. I'm not going to write any examples yet. I'm going to basically just see if all my testing configuration is correct. So I'm going to go to truffle test. I'm actually going to clear this so you can see. Say truffle test, and I can pass it the file we want to. Test Dapp token Crowdsale. And also make sure you have Ganache CLI running, or Ganache, the... All right, so it looks like I have an issue here. It looks like I just used the wrong file name. So yeah, truffle test, and we'll use the test directory, Dapp token Crowdsale.test.js. I just forgot the test here. So we'll run that. Let's see what happens. All right, so 0 passing, which is what we expect because we don't have any examples yet. But the before filter, the before function seemed to work. So we can see a transaction was created here. These were actually getting migrated to the blockchain. There don't seem to be any reverts or anything like that. So that's good. So I'm not going to test every bit of behavior about this crowd sale, right? It doesn't make sense because this crowd sale is actually pretty well tested inside of OpenZeppelin. But I am going to add just some sanity checks that ensure that our crowd sale is working properly as we add on to it. So I'll just write some basic tests just to say that the crowd sale accepts payments, that it tracks the token, things like that. All right, so the first thing I want to do is basically test that these variables were set correctly whenever we deploy the crowd sale. And what I'm going to do is basically we're going to describe the crowd sale, say describe crowd sale, pass it a function, and we'll close this out. And the first thing we'll say is that it tracks the token. So we'll paste that in. So we can read through this. Basically, it tracks the token, and this we're using the async await pattern like we used in the last example. We say const token equals await this.crowdsale token, and remember we're using this chai should, and we say this should equal this token address, which is what we use when we deployed the contract. So this is why I assigned all these variables to this, so we can use them down here in our examples. So in order to run this, we've got should, and I think we've got everything we need. So let's just try that. All right, seems like it's failing here. Cannot read property token if undefined. All right, I see what happened. So I overrode this. My fault. Crowd sale. So yeah, I actually like to leave these errors, these mistakes on camera because it shows you that I'm not perfect and this is what software development actually looks like. So yeah, I'm just going to assign this to crowd sale and basically say this crowd sale.token and this token should equal token address. So let's try to run that, see what happens. All right, there we go. And let's test for a couple more things. We'll just say that it also tracks the rate. This is pretty self-explanatory. Works just like the other test. We weight the rate. Weight should be, well, this time it's big number, which we used in this Dapp token test. Decimals should be big number equal to decimals. Same way, rate should be equal big number to this.rate. And in order to use that, we've got chai big number wired up. So let's see if that works. All right, tracks the rate. And we also want to say that it tracks the wallet, which is, this argument here. So save that. And there you go. So I'm actually going to reorder these to reflect the constructor arguments. So rate wallet token. Let's move token to the bottom. Clean this code up. And let's save that. Run the test again. All right, it works. All right, and that's it. So that's a basic setup for creating a this Dapp token crowd sale. And that's where I'm going to stop today. We've got a test for this to test for a basic crowd sale to test that it's got the basic attributes we want. And so be sure to subscribe to the channel for the next video when it comes out. In the next video, we're actually going to turn this into a minted crowd sale, and we'll test the minting behavior, that tokens are actually minted whenever you purchase them. So until then, thanks for watching Dapp University.